Well, hello, everybody. Good morning to Americas. Good afternoon to Europe. Welcome to UV LED webinar. SOMA UV LED webinar. This is the second webinar of today. We have more than 350 people registered, and already one webinar for Asian markets are behind us. Successful one. So we hope it will be the same right now. My name is Peter Blasko. I'm a marketing director of SOMA. And the goal of today, of course, it's the UV LED technology. It is the status where we currently are. We will share the main benefits of this technology, but we will also focus on the challenges that are connected with this fastly developed technology. So let's look at what is ahead of us. Let me start the presentation. We will spend approximately 1 hour together. My fellow panelists will help me share the 3 presentations, each of 10 minutes. Flint will start with the presentation focused on development in UV ink and also on food compliance issues. Niklas Olsson, Global Brand Manager for NarrowWeb. Later, Adam Roback, Regional Sales Director from Fosion, will share about the drying system, UV LED heads, as well as the market segments which this technology is used for. After that, I myself will speak about Optima printing press, the press which we will use during the demo to print 2 food packaging designs using this technology. And after the demo, we get back to here to the room and we give you a possibility to ask questions and answers. And you may ask questions during the presentations. To do so, please use the Q&A button on the bottom of your page. Don't use chat, please. Use Q&A. And if you would be so kind, please also address the question either to Fosion, Flint, or SOMA, or to all. Okay, now it's time to introduce the other panelists. So let's connect to Sweden, where Niklas Olsson is, and let's connect to Germany, where Adam Roback. We have to unmute other colleagues. So hello, Adam in Germany.
Hello, how are you?
Quite well, thank you. Nice to see you again.
Thank you.
Good afternoon, Niklas.
Hi, I'm fine.
How is it in your kitchen?
My kitchen is getting around. I have the sun from the west, so it's almost soon like in Oregon. Or where are you, Adam?
Yeah, I'm almost in Oregon. The weather is always beautiful here. Sun is always shining, even in the afternoon. Yeah. So now I'm based in Germany. It's just our headquarters that are in the background.
Well, I can't get so fancy backdrop, so I use my old-fashioned printed backdrop, working from home.
Well, I think that looks nice. Look at the painting behind me. That's a branding, our new branding, SOMA branding. A piece of art. But yes, we will also speak about the piece of art, state-of-the-art technology. So now it's your time, Niklas. Please start sharing your presentation, and we give you a spotlight.
Okay, let's see if this one works again.
Yes, we now see your presentation. Very good.
Good. Well, thanks for organizing this and welcome everyone. And my name is Niklas Olsson, as said, and I work for Flint Group and I work for the NarrowWeb division. I think most of you know Flint from many different applications that we have in our portfolio, from packaging inks to wide web inks to printing plates. But being representative of the NarrowWeb, we have what I could call UV inks in our DNA, or innovation of UV inks in our DNA. We have been active in this market for 50 plus years, narrow web UV technology, and have a few milestone developments behind ourselves, one together with Phosion on the LED Flexo. It may sound strange to many of you, why is the guy from narrow web labels talking to wide web Flexo packaging? But we decided that with our knowledge and experience in UV curing technology, we will within Flint have the drive of, say, developments. So yes, there might be application knowledge that we lack. Then we will call in support from other experts in packaging ink division, and then work around with, say, the UV technology to make it work on the bespoke application in mind. With that said, I want to also give you sort of a background to UV technology. I believe that is maybe new to some of you. I know there are a lot of myths and misconceptions or perceptions out there that UV ink is not safe for food packaging. And I hope by these 10 minutes, I will take all those things away, because there are several advantages with UV curing technology that can also be used in flexible packaging or food packaging print. I think one of the main advantages that we see is obviously that it has no solvent. It's totally solvent-free, no emissions at all, and it cures by a polymerization technique, or polymerization, yeah. So the UV ink technology that's been around for most of times is what we call mercury. You cures with a mercury lamp, a UV lamp. And fundamentally, that technology that is proven has been around for a long time, is pretty similar to a UV LED ink from a buildup and from, say, a chemistry point of view. There are some fundamental differences which we will highlight here, and one of them are the photoinitiators that are being used in LED ink versus mercury lamp. But yeah, you use pigments, you use binders, you use monomers to make the ink at the properties that you like, and the cure, say, the performance you like, whether it's an offset or flexo ink, and you use different additives to enhance final performance. The UV LED curing process is, as any of these UV technologies, the ink you apply to substrate, you expose this to UV light, photoinitiators will react to the light and form, say, free radicals, and these will initiate the polymerization of the binder. So nothing evaporates, the binders cross-link and form a strong chain that adheres both to the substrate but also internally, so you get, say, a solid ink film. Again, I can't say this too often, but solvents do not evaporate during this process. This illustration here is again, referring back to mercury lamps, where you have a wavelength spectra in a UV mercury lamp that goes from 200 nanometers up to 420. And different lamp types can have different, say, peaks and troughs in this wavelength area. So it's all over the place. And to be honest, it's needed to cure some of these things that you see. The pigment illustrated here by a red, yellow, blue, and black line, the pigment in these inks absorbs the light. And that's why we see the different colors. This illustrates that red ink is the easiest to cure because the pigment absorbs less light. Black is the hardest because that absorbs almost 90%, 95% of all light, all UV light that we emit. And that's very known to the industry that, say, black inks are hard to cure. If we apply LED light, UV LED light, there is a very bespoke wavelength area where the lamps emit the light, or the diodes. And that's 390 nanometers. And it's then obviously very important for the ink supplier to say, make sure that photoinitiators are reactive in this area. And you can see also here that, say, the benefit of having this wavelength is that black inks, for example, are easier to cure and cure better than they do with mercury, because the pigment actually is not so absorbent in this area. Another factor that we've seen, or say a fact with the 395 nanometer, is that LED inks have a better penetration of the ink film, and the longer wavelength penetrate any ink film better, and therefore you get better bond strength, better adhesion, and better through cure of your ink film. So that's also a benefit that has been proven over the years. We take some of the benefits with UV for granted. Thus, it's maybe somewhat we feel complacent when we talk about these very strong benefits that we'll get by, say, a solvent-free technology. In the narrow web market, UV technology has been around for 20-25 years, and it's been going through the same sort of competition against solvent and water-based that we now foresee in flexible packaging. But the benefits are clear. Here's one example that we saw in what we did for a shrink sleeve application where we did directly one-on-one. The UV Flexo has much better, crisper print quality, much lower dot gain, better resolution, and also all the benefits you can get with printability. I don't take this for granted for the ink. I know there are a lot of technologies that have been developing over there. Plate technology is one that recently, so you now have much finer resolution in printing plates available, and now you can sort of clearly rival both gravure and offset technology with Flexo. But you say printing with UV on packaging, that must be silly. And maybe it was 25 years ago because, yeah, there was some, it was uncharted territory. But today, UV technology is proven and tested to be, say, meeting all the demands that you have in the most stringent demands for packaging print. And in fact is that there's no separate demands on UV technology. It's the same criteria we need to adhere to as for any ink system, whether it's solvent or water-based or oil-based. They all need to, say, be of the right base to meet, say, packaging demands. I haven't said it, and I know this has been, say, mentioned before as a reference to low migration inks. And that terminology we don't use anymore. It's been decided in EUPEA that the right termination should be food contact material inks. And there are, say, a well-defined description of what is a food contact material ink and when can we not call it that. And these demands are the same whether it's a solvent, water, or UV ink. You cannot use it unless you meet these criteria, and you can prove that you meet these criteria. So one could say that, well, food packaging, it's all down to the ink maker. And in this very simple analog here, I will show you, well, yeah, you could say that if we supply ink in the egg, and it's obviously very important what we select to be in that ink, in that container, but then that ink is being processed, printed, used in some sort of, say, different, say, application with plates, analogs, lamps. And in the end, the final end use should be, say, what substrate, what, say, how is the package stored, what are, say, the outer demands on the package. All these three elements together form, say, how you can build, say, a safe packaging. One of the most obvious ones, obviously, what substrate you print on, is it with a functional barrier or not. And if you have a functional barrier, then you don't need to worry too much of, say, your food contact material as ingredients. If not, you need to put, say, some requests on the ink supplier, but also you need to look at, say, not only his, say, what he put in the ink, but also that he has, say, a good manufacturing practice in place, which I would say many or most of us involved in packaging printing have. One thing that you might forget, or if you're new into food packaging, I think you also should pay attention to GMP process in your own printing press or in your own premises, because there are some stringent demands on how you can keep traceability and how you put track record of what you actually did. And I think here, say, LED also offers, say, significant benefits to keep sort of process control of, say, how you print and the lamp operation. When we say food contact compliant ink or low migration ink as the old definition, we said it has to comply with the following regulations. And I apologize, there's not one single one that, say, makes or break this, but I think Swiss Ordinance and Nestle Guidance Note are the two main that people refer to today as modern requirements. But all of these we are taking into consideration before we announce that, say, ink can be used for food packaging. And we will obviously, in getting into that situation, support clients that say go forward with all the different means of how to prove to brand owners that everything is in good place. The ink that Soma will be using at the demo that you'll see later is EcoCure Ancora. It's fully compliant with Swiss ordinance and Nestle guidance note. It's an LED curing ink that we know and tested and proven it will withstand most stringent migration tests. And in this case, I just referred to 95% ethanol, 10 days. That's being quite stringent demands and pass all the migration requirements you have. Now, going back for 2012, when we started to develop this together with Fosun and others, we obviously took the first steps into the world in narrow web, and labels were in place, but it also have evolved quite rapidly over the years. And all these applications that I highlight here on this slide have been tested. Ink has been used on all these and very successful in commercial applications. My final slide and a nice sort of lead over to Fosun is, I think this is the one slide where there's a lot of benefits that we've seen from converters that started with LED, with the lamp technology and this. But this is the one that I feel is the most sufficient, strong one that with having an assuredness of cure over time. With a Mercury lamp, we know that the degradation goes fast. You need to change lamps. You need to keep reflectors clean. There is a uncertainty involved. With LED, you have a very strong assurance over time that this will emit the intensity needed, and you'll have assuredness of cure over time. And I think this is give you peace of mind and also your customers a peace of mind. Well, that was a little bit of the ink part. Now I'll leave over to Adam to take you further into the LED lamp part.
Mm-hmm.
Thank you, Niklas. So I will now start sharing my screen. Okay.
Very good. We see it well. So
perfect.
Go on, Adam.
All right. Well, first of all, thank you very much for attending this seminar. So many of you again. Thank you to Soma for organizing it. It has been a great event this morning, and it looks like it's well attended in the afternoon as well, the afternoon for us here in Europe. So Fosun, who have equipped the Optima Press that you will see later on running, we want to give you more benefits of UV LED technology for CI Flexo, and show you what this technology can do for you. First of all, some words about Fosun. With 18 years of experience and 100% focus on LEDs, Fosun can claim that we were the first ones to develop UV LED lamps for the industry. With over 2,100 installations and over 80% market share in Flexo, that's white and narrow web combined, we are the market leaders. And you will see in my presentation also why we are market leaders. It has to do with the innovations that go into each and every lamp. Fosun is a US-based company out of Portland, Oregon, but we operate worldwide. We have sales and a support network in Europe, in Asia, and in the Americas. And this is especially important for you as a Soma customer who is thinking of maybe purchasing a machine with our lamps. You will have also local support in future for our product. We work with a UV LED support network, so you are in good hands, first of all, of the press manufacturer, Soma, who integrate the lamp with our help, and it's fully integrated into the machine, with Flint as an potential ink supplier, and a very good partner in UV LED inks, and with Fosun, who all three together support you as a team. So now let's go and look at the lamp that we will be showing you at on the Optima Press. Well, it is a UV LED lamp. There are no mechanical parts, so there is really almost zero maintenance, and each and every lamp packs 229 international patents, which is really amazing for such a, let's say, small product that you see here on the slide. But these patents are important so that Phosion can offer you a high dose and a high power lamp, which curing at high speeds requires nowadays. And the Optima Press will be running at almost full speed. The actual live test data of our lamps shows you that even after 60,000 hours, and that's 16,000 hours of operation, so we only count the on time, as LED lamps can be switched on and off within 20 milliseconds. So 60,000 hours of operation, and we are still at L90. L90 means we still have around 90% UV intensity. So this is well within the operating window of UV LED ink. So why is UV LED in CI Flexo actually a good fit? Well, UV LED inks, as Niklas already mentioned a couple of times, they do not contain any solvents. So what does it mean for you? Well, for you, it means you don't have to clean the machine after every shift or unexpected stop like a power cut. So the ink can be kept on the machine, and you can come back the next day and simply start the press off. It does not cure without a lamp. And this is a very important message here. And also the ink, as it does not have any solvent or water inside, it's really the ink behavior and does not humidity and temperature does not have any influence on the ink behavior. So also no controlled press environment is necessary. There's no solvent. Again, we mention it because that's a big plus of UV LED. So you don't need an extra oxidizer in case you are thinking of a new machine, or any solvent recovery system. No ink or viscosity monitoring system is required. And the machine, for example, that we will be showing today does not have ATEX, as the ink is just not really explosive. No solvents or ammoniac means no smell as well. UV LED lamps give you the benefit of a very much reduced heat transfer on filmic material especially, and on the CI drum. So no additional chilling capacity is required for the drum itself. And the UV LED drying is drying directly after the print station. No drying tunnels are necessary, giving you a much smaller footprint for your press. Again, the easy maintenance that I want to mention here again, it's basically just cleaning the UV emission window, as there are virtually no spare parts. The mechanical press speed that is achievable, well, it is, let's say, full speed with your press. So what benefits do you get in CI Flexo from UV LED lamps and inks? We identified here with our partners and customers who are already running UV LED lamps in CI Flexo. We identified three major topics, let's call them. The first one is we call it the advanced capabilities. So this is what you can do more with your press, and it gives you the possibility to run short print runs or just-in-time delivery. And a very good example will be the show that we will be seeing here with the Optima Press, as they change jobs within minutes, which is virtually impossible with any other ink technology. The preheat sensitive thin substrates, they can be printed much better, much faster. The consistent and controlled UV curing process and the parameters that we give you just gives you the full control of your lamps and the full control of curing. When you use the same parameters with the same substrate, the same ink, you will get the same results. It will not depend on the environment, on the operator, or any other external factors. The ink itself will give you brighter colors compared to water-based and solvent-based technology. And the lamps are IoT and Industry 4.0 ready. So we like to call them digital curing, as they are very different to the analog system of mercury-based UV lamps. The economics, well, there are different factors here. Again, monolayer substrates, and an external print is now possible without lamination, as UV LED inks give you this possibility. Higher alcohol prices, especially nowadays with the situation that we have now and all alcohol being used by pharma, you see a spike in prices for solvent-based inks, and UV inks again have no solvents, no alcohol in them, so the prices are very stable. No solvents means no oxidizers or solvent recovery installation required. Virtually no spare parts like reflectors, shutters, bulbs. This is all when you compare it to a standard mercury lamp. But again, no mechanical moving parts in the lamp. Reduce scrap and improved yield by a consistent cure. So the lamp will not cause you any problems when setting up a job. The lamp does not create ozone. If you have been thinking about UV and you have come across mercury, you always see these big exhaust fans. What do? They suck out ozone from the lamp that is created by the mercury lamp. They also suck out a lot of air out of your factory, creating an under pressure. This does not happen with UV LED, as the lamp does not create any ozone. The environmental factor now is becoming bigger and bigger. The lamp uses 50% less energy, and also it reduces your CO2 footprint. It's mercury, which especially in Europe and other countries is very important, as mercury is being banned. There are no VOCs, so no fire or explosion hazards, and monomaterial, which was mentioned before. It's mentioned here again. Why? Because then if you don't laminate it, it's very easy recyclable. So let's move on now to some markets and applications that Soma and Flint and Phosian defined. And one of them would be shrink sleeves, and shrink sleeves will see a huge benefit out of UV LED, as the superior opaque whites that you will get out of the UV LED inks and the curing process will give you also higher speeds. The material is more scratch resistant. There is very low IR impact, so heat impact on the sensitive material, which means you might be able even to run thinner materials on the same press with better shrink properties. The next slide and the following ones, they show you different products, and the benefits of UV LED inks will always be very similar, because UV LED ink will give you this glossy and rich colors that Niklas showed you before in more detail, and they're especially important on certain packages like pouches, stand-up pouches for different products. You want these rich colors because they sell your product. You don't want these damp grayish colors. So you want the scratch resistance, as they are packed together one next to the other. And the same goes for energy cereal bars or power gels. Again, glossy and rich colors, a superior opaque white that is often needed, and the scratch resistance. This all will give you UV and especially UV LED in that sense, as you can run double or even triple speeds with your press than compared to mercury. Laminated foil and paper wraps, well, that's a direct comparison to solvent and water-based. Why? Because it's very difficult to print on these porous materials with solvent and water-based inks. So UV LED inks, and here we have to say UV LED only, not mercury, will give you really superior results on these porous materials, as the ink will just stick and the quality will be in some cases very similar to offset. Yogurt and aluminum lids, in general, well, again, a very porous material, and you can immediately see in any shop if it has been printed with UV LED or solvent water-based, as the colors, that they just don't pop, they just are not glossy enough. And also you don't need overprint varnish on these. So this concludes my part of the presentation, and now back to Soma, to Czechia.
Thank you, Adam.
Thank you.
Yes, and thank you, Niklas, as well. So now the third presentation, which will be focused on the printing press itself. So let me start our presentation. As we have heard quite a lot about UV technology already, I will focus on the Optima Flexo press, and later in the second part of my presentation, I will focus on the UV LED modifications to Optima Flexo. Optima was launched at 2013 at K-Show. Last year, we reached 100 installations worldwide. I'm showing this slide to show you where the installations are, but also want to share the main message that we do not only share or deliver the technology, high-tech technology, which I will introduce later on, but we also sell it together with services. Step by step, country by country, installation after installation, we offer service support as well as partnership. So if we take a look at the short-run Flexo family, Optima Flexo family, the press which we will see during the demo is the one on the left-hand side, a startup press, mid-web segment, Optima Flexo, the smallest one in terms of the width as well as repeat length. But UV LED technology could be implemented also to Optima 2 mainstream Flexo, which is 1.3 meters wide, or even to the 10 color or long repeat length. So there are really not limitations for UV LED. Currently on the market, we have several Mercury UV presses. We have one UV LED press on the market running more than for 1 year, and the press which we will be demoing today is going to be delivered to customer also soon. So there will be 2 UV LED presses from us as we gain the experience. Let me advertise our next webinar, which will be at the beginning of July. We will call it Drupa webinar, and that will be webinar focused on the intelligent features. We implemented and developed several intelligent features to make Optima even better than what it is now. And it's our secret development, but we will reveal it in the upcoming webinar. So initially, as I have seen that the audience is quite a few people from narrowweb business. So Optima was, it's CI Flexo, of course, and that gives a possibility to print several different applications. In terms of inks, it's quite clear, solvent-based, water-based, or energy-cured inks, UV or EB. In terms of paper substrates, we have possibility to print Optima prints thin wrapping paper or paper cup, which is very thick and rigid material. And same with the plastic. We may go low density polyethylene, just a few microns, a diaper membrane, or we may print quite thick lids or shrink sleeves. Of course, new environmental substrates and applications are feasible to print on Optima. And special substrates, such as casings. This is quite interesting for a UV LED technology. Today you will see also turning bar system on the printing press with in-register reprint unit. All of it together with UV LED could be applied for the casings market segment. And mainly due to the downstream stations, various coatings could be applied. So again, this gives a wider range of applications possible. Optima was designed for expanded gamut printing. This is a must for the future. So let me answer the questions. How is it possible that we handle all of these applications? Well, this is due to the 4 main reasons. First, exceptional print quality. And this is one of the unique features on the press design, which you see on the right-hand side of the picture of the printed area and non-printed area in rotational process. in the wider web width, the narrow web, creates vibrations. And this is what every CI Flexo press manufacturer has to deal with. And we developed advanced bounce control system, a unique system available by Soma that eliminates or reduces the bouncing down to minimum. So that gives you the possibility to print the problematic designs with higher speed. And this is due to the rigidity, meaning how strong the construction is, due to mass, how heavy the printing unit is, and also due to damping properties, what kind of material we use to minimize the vibrations, carbon composite, cast iron, for example. Let me mention one more thing. In the next upcoming webinar, we will launch a second generation advanced bounce control system with one new intelligent feature that really improves the print quality. Not today, at the beginning of July, it will be public. Side frames, extremely heavy, very rigid, made out of one piece for small Optima. CI drum just goes in the middle, made out of cast iron. Okay, so again, the very good dynamic properties. Reason number 2, to be able to print all those different applications. Customization to your specific needs. If we take a closer look at the design of the press, not only that it's one of the smallest one on the market in terms of CI Flexo, but we divided the printer and roll handling area so that the right-hand side of the press could be modified according to your specific needs. That part we could adapt to your specific application during the production, of course, of the press, or later on as the retrofit. So different winders possible, but mainly different downstream or upstream stations. Flexo, Gravure, digital, UV, solvent, water-based, in register, reprint, coating, varnish. All of that possible, providing several different options in terms of application. Reason number 3, yes, short runs. Long runs are history, short runs is future. We developed a technology that minimizes the job changeover. Here, maybe I reveal a little bit about the upcoming webinar, not today, but in July. We will show you the new automatic plate mounting. We try to automate the process, so we will automate the plate mounting, meaning it will be quick, without human error, very precise process. As part of the automatic plate mounting, we will measure the register as well as the topography. This is the ARUN technology, so that later on the press, we would set register and impression in fully automatic mode without human operator mistakes. That's called ARUN technology. Wait for a next webinar. Today on the press, we have Falcon 2 system, semi-automatic system. But since we are focusing on the UV LED technology, we will not use ARUN, we will not use Falcon 2, we will use recipes to do the quick job changeover. If you are interested in a really high-tech changeover technology, wait for the next webinar. And cartridge system, this is what we will see today, because that's really a special feature only available by Soma. And for UV LED, this is quite handy. It is an ink compartment locked directly to ductor blade chambers. You see here the small houses. So we omit the long housing and the whole inking system. The cartridge is locked directly to ductor blade chamber. So we start to print with minimum amount of ink. And also for the wash up, there is a minimum a residual ink in the system. So application, metallic ink, or Pantone, which has a very small area to be printed, or UV LED ink, or any expensive ink. This is to minimize the residual ink in the system, in cartridge. And the last reason, and then we go closer to UV LED technology, it is environmental printing. Okay, Optima was designed for hybrid solvent and water-based presses, as well as for energy cured, which are considered environmental, and this new biodegradable substrate. So when we go to UV printing, now I speak in general UV, this is a green technology. This is what the brand owners would like to have. No emissions, no solvents, VOC emission-free printing. As we heard, there is a higher pigmentation in gloss, so therefore we may use less ink for the print. Okay, so the amount of ink to be transferred on the substrate is much less than comparing to solvent-based. And we do not have to do any wash up, as Adam said, at the end of the shift. Again, no solvents involved. And in connection to EGP, this is efficient, but this saves nature also. When we take a look at benefits of, especially of UV LED printing, there are several other benefits. 50% less energy compared to the conventional UV. There was a question regarding the speed. Yesterday we will print 300 meters per minute, both of the designs. Several other benefits were mentioned before. So let me get to the point to introduce the press which we will use during the demo. So as we said, it's a mid-web version of Optima. Maximum speed is 350. The web width of the press is 1 meter, 650 millimeters repeat length. The press is equipped with slitting unit up to 5 slit rolls, with turning bar system together with in-register reprint unit, or so-called in-setter. And we said it is EGP ready. And in terms of UV LED features, okay, one special feature is a unique cartridge system I already spoke about. Then the press has ink thermal stabilization, so that we keep the ink in desired temperature range. We developed ink connection swap system for easy changeover. This is going to be introduced by my colleague Roman. And quite interesting is that this printing press has a water-based drying tunnel. So we have the heads around the CI drum, but we may apply the water-based coating. The two designs which we will print, you see that there will be a white all across the image. We will print on the metallized film. It is a food packaging design. Again, my colleague Roman will share a bit more. Maybe we can now also show the videos from the production. I will maybe mention regarding the demo. Now let's go for the demo. I mentioned one thing. Currently the press is in production, so the situation is not ideal. Our next webinar will be in our beautiful Globe Technology Center, but today we will be a bit limited in terms of space and surroundings in our production. So let me hand over to my colleague Roman Dressler from Globe Technology Center, who will be so kind and guide us through the demo.
Okay, ladies and gentlemen, good morning. good afternoon. Welcome to our afternoon show. This is the last show of today's. I think that everybody is missing the exhibitions. So let's feel as in Düsseldorf. And in the same way as at the show, we prepared the today's demo for you. So it will be simple. It will be confirming everything what my colleagues from Foseon, from Flint, and from Soma said. And hopefully you will like it. David is already standing in front of the printing press. Hello, David. I hope that you can hear us nicely and everything is prepared for today. Yeah. So today's demo, we will start not with printing itself, but we will start with the printing press introduction. As Peter mentioned, we are printing on the Optima printing press, which was optimized for printing by UV LED inks. And I will just slowly start introduction each part of the printing press, so you can learn the modification what we implemented inside. And Andrew, our cameraman, Andrew, I will ask you if you can now focus on the ink pumping unit and the ink connection swap system. As the inking system was adjusted in order to print the UV LED by increasing the hoses size. And we implemented this connection swap system in order to make the ink order change, ink order swap inside the printing unit easy. It means that we are not performing the washout during the changeover of the inks, but we simply disconnecting these pipes, what you can see in front of you. Then we remove the Dr. blade chamber from its position and we'll put it in another position. This can be done easily without washout, which saves a lot of time, which saves the ink, and which saves a lot of money. Now I would like to speak about the ink cartridge, what Peter already mentioned in his presentation. This ink cartridge is the unique system which you can get only from Soma, nowhere else. And it means that this is this ink compartment which is directly connected to the Dr. blade chamber. And you fill up this cartridge with the ink and you can start printing with as low volume as 1 liter. Just 1 liter volume to start printing. Expensive ink, silver ink, thermal sensitive inks, Pantone for small areas. It is the ideal solution for it. With viscosity, with ink pumping, with automated wash-up system. So above the ink cartridge, we will focus on the Foseon lamps, UV LED lamps implementation inside the printing press. So you can see with that you get very easy access and it's a very efficient solution for printing, for implementing. Now I will ask our cameraman to walk alongside the printing press, and David, our printer, he will start printing the first job, slowly the first job. We are walking alongside the printing unit, 8 colors printing unit, now focusing on the reprinting unit, or if you want to, Insetra. And above the Insetra, there is the hybrid water-based drying system. It means that this is hybrid printing press, which allows you to print LED UV ink as well as water-based varnish in the last printing deck.
So the tunnel, right?
Yeah, we're talking about the tunnel, correct. Now we are focusing on the graphic control camera, which is positioned very closely to the viewing place and very closely to the printing unit itself. And at the same place, you can see the turning bar. We are not using the turning bar today for this application, but this is the, I would say, very efficient way how to perform the both-sided print during one run. Now we can continue to see the non-stop unwinder and non-stop rewinder. The construction of the printing press is variable, so the customer can choose if he would like to have the simple unwinder and simple rewinder, or if it can be modified directly in Soma or later. Now you can see the slitting unit. The slitting unit can be either with razor blades or with the rotary knife. We have got implemented the Maxxis rotary knives up to 5 slits, including the edge removal system. So we can walk back to the operating place where David already set the first printed job. And we will be speeding up to 300 meters per minute, which would be, in this case, our normal production speed. We will not take a sample, a physical sample from the first job. We will inspect the print, in this case, on the screen and in the viewing area.
Maybe take a look at the web camera again.
Okay, we reached the speed 300 meters per minute. We can check the camera itself, camera screen, and David will stop the printing press, and we can review the printed sample from the viewing place.
Nice.
Everything is nice.
The inspection area, as you see, is very close to the operating panels. So virtually making just one step, and you get very close to see what the press actually is printing.
We are printing CMYK plus white on a metallized BOPP substrate. This is a production job. It is food appliance job, printed and sold here in our country. So in detail, you can see that the coverage of the ink, impression, registration, it's perfect even with the speed 300 meters per minute. And Andrew, if you can now focus on our partners, which are working with us together on this project, as Flint with its LED UV ink, Apex for Analoxys, A-Studio Group helped us with the graphics for these jobs. Cassia is the owner of these production jobs. Panflex prepared these printing plates for us. Lohmann for sticky back, Kodak for NX plates, and Foseon for LED UV lamps. I will take this opportunity, and I would like to thank to our partners for supporting Soma with this project and other projects which we're going to present for you in near future as well, as the Drupa development, for example. David is now already exchanging the sleeves, preparing the printing press for the second job. Optima can be operated by one operator, or actually the correct number would be 1.5.
Yeah. This is interesting. For the wide web printers, Optima would be considered as a small printing press. We really try to make everything reachable from ground, and we designed the press so that the web is accessed very well from each single point. But for the narrow web printers, Optima, as I spoke to the customers, it's quite a big printing press. So depending on the point of view, but very well designed ergonometry to operate this printing press for sure, if you compare to any other competitor CI Flexo press.
That is why Optima, this mid-web segment Flexo, is considered as the next choice of narrow web printers if they would like to step into the flexible market.
Correct.
Now you can see that we are setting the second job from the recipe. We omitted the setting job with the semi-automatic system Falcon 2 or fully automated system ARAN, because in this demo we wanted to focus especially and directly on the LED UV print technology. So that's why we keep it very simple. And if you would like to learn more about the job setting and about the Drupa development, you can join our future webinar where we will be talking about another equipment development surprises what we are introducing to the market.
So at this point, we printed the job earlier. We stored all the data regarding register and impression and other settings in the recipe, and David just recalled the recipe from the memory. And there instantly we may start to print. You said it's 1,000 recipes, Roman?
More than 1,000 recipes.
Yeah, available.
So indefinite number in this case.
Mm-hmm.
This second job, we will be printing with the speed 300 meters per minute as well. But the difference to the first one is that we will cut the sample from the Rewinder.
Mm-hmm.
So we can see the stable picture, perfect registration, perfect impression, printing with maximum speed. And now, David, please, let's take a sample at the Rewinder.
Mm-hmm. At full speed.
At
right?
Full speed. And when we take the sample, then we can stop the printing press.
The press is so quiet, I don't hear any noise. But it is quiet, but basically for the wide web printers, you would be very surprised because there is no heating, no ventilators, no fans of the heating tunnel. So this is really, when printing UV LED, this is for the wide web printers, this is quite interesting, the quietness, the noise level of the press.
The best way would be when we get an opportunity. This demo is actually as an invitation for you to come to SOMA also when the time allows to see the demo or trials directly in our SOMA Globe Technological Center, as we are fully equipped with the machinery and with the environment in order to perform this type of trials and demos for you in order to get the confidence in our machinery and our services for you. Now David has taken the sample from full production speed, 300 meters per minute. And I will ask Andrew to inspect the printed sample closely.
So again, this is food packaging, some sort of soup or maybe?
It is a soup and it is a shake. So it is mixed production.
Ah. The same partners.
The same partners. Peter will speak about the samples that at later stage we will be able to share the samples with our sales guys and representatives. So you will be able to inspect them on your own eyes as well.
Very good. Very
okay,
well.
Gentlemen, I would like to thank you in our production hall, in our playground. I would like to thank especially to David. And gentlemen, I wish you have a nice evening, nice day. And once more, thank you very much.
Yeah, okay. Thank you, David. Thank you, Andrew. And let's get back to our room and for the question and answers, because we still got some questions to be answered.
Okay, I will say goodbye for myself, and I will pass my word to Peter.
Thank you. Here we are back again. So let's connect, please, panelists as well. And
hello.
Hi, Niklas, back again.
Hello.
Yes, good. And we will also ask Herman Horters, Business Development Manager of Fusion, to join us, if in case he has any questions. Jan, please share all the cameras. It's fine if there are presses. We will disconnect them later, but it's okay. Hello, Herman. Hello, Niklas. Hello, Adam. And
hello.
Hello, Peter. Hello, everybody. Thanks for having me.
And let's take a look at the questions and answers. Is there an email subscription list or how to register for the future webinars, including the Drupa presentations? Yes, we will communicate after this event. You will receive an email and we will show you how to register. Do we have a comparison in terms of price for printing with solvent-based inks versus UV LED inks? I think this is a question for you, Niklas.
I was just starting to type a response to the question, but yeah, I mean, we do have, I mean, I think it's a, you need to look beyond just the cost per kilo. We can compare, I mean, if we just do cost per kilo, UV inks are much more expensive. If we look at, say, one step down, the printed cost, the total applied cost, a solvent ink contains 50% solvent that will evaporate, so you don't use that, whereas a UV ink is 100%. And yeah, you use less ink, and therefore I think, say, printed cost is lower and comparable. Then the other benefits you'll have with UV is obviously the benefits with the energy consumption and so forth. So I think I would do, if we do a total cost for this, I would be very interested in the outcome. I'm pretty sure that we are very close to being cheaper, but if you just look at ink per kilo, yeah, a UV ink is 5 times more expensive.
Thank you. I see one more question for Soma. Can we get the samples? Yes. We will distribute these samples via Flint as well as via Fusion. And yeah, if we are able to travel, we will visit you. We will be glad to visit you and provide you with the samples. If not, our agents could do so. So our sales network, we will distribute the samples. The next question, in Pakistan, there are no local producers of UV LED inks, whereas other solvent-based inks are cheap. Niklas, could you relate to this somehow?
Well, I know that we are trying to, we do have, say, supply and distribution into Pakistan, but yeah, some of the challenges that we see is, say, with local requirements being, what do you call it, either tax or import duties, etc., a challenge. But for sure, we do supply to printers in Pakistan with also UV inks. So let's talk to our agent or our close supplier and we can figure it out. The second question, I think, laminate. Yes, we can laminate. I know we have different types of, say, both UV laminate or, say, which then is solvent-free. I would say that when we took solvent-based, solvent laminate adhesives, we have less experience with that. I know we've done some with normal solvent-free component lamination in line. I know one of our other machine supplier did demonstrate one lamination technology at Label Expo in line that was also solvent-free. So there are several different, say, possibility to laminate on top of the UV ink.
There's a question regarding the construction. Yes, there are 7 UV lamps around the CI drum, you know, after each printing unit, and there is one less lamp after the tunnel against the cooling cylinder. Next question, again for you, Niklas, is there UV inks 100% food grade with certification? Yes.
I'm obviously a little bit careful to say yes categorically to everything when we say food grade, but yes, for use on food packaging, not direct food contact. I think there's no ink that actually is, say, approved for direct food contact or very special inks. But yeah, these UV inks are definitely certified to be used with food packaging.
So they are, Niklas, they are certified just like the solvent and water-based inks, right?
Similar, yeah.
Yeah.
How many machines regarding UV LED? This is the second machine, and regarding the UV, we built maybe up to 10 presses in the past. There is one customer in Czech Republic which is using 3 UV presses from Soma. That's a great, and printing food packaging. Usually he's willing to open his company. So that's a great example of very successful UV CI Flexo converter. In cartridge system, yes, this is a new version. It has we now have different versions of ink volume. We have a new level control and measuring, so you see the ink level constantly, and new mixer for the metallic ink, and also a different design and shape there, especially for metallic inks. So there, yes, ink cartridge has gone in improvement, and we want to make it continuously better as this technology improves. Does dry lacquers from 1.5 to GSM?
We are talking about the dry or wet?
Is it dry or wet? Maybe dry, I guess.
Maybe dry, yes. I don't see any problems.
No problems with that. My colleague from Globe Technology Center, Moreno Melegate, is answering the question, as he's the specialist, application specialist here. Can we laminate with extrusion coating process?
Does this mean that you want to extrude? I assume this would mean that you want to extrude polymer film on top of the UV ink. I think this is something we need to test. We haven't done. We printed on new extruded polyethylene or polypropylene, so I know we can print on top of, say, extruded film, but whether we can laminate with it, it's a little bit unknown. But I would say I don't see any problem why you shouldn't be able to adhere to the UV ink.
Mm-hmm. Okay.
The second one with counterfeit, yeah, there is, but they are so then. I mean, that's a special anti-copyable ink, so the security application. So we do have that also in UV.
Mm-hmm, mm-hmm. Yes, and the other question that was already answered, the comparison of UV LED compared to solvent-based. But let me finish the question and answers by saying all of you will receive a follow-up email with our email contacts. So we kindly ask you that you ask these questions which were unanswered directly to Niklas, to Fosion, Herman, or Adam, or myself in Soma. Because the time is up, this is what we said, 1 hour and plus 10 minutes. Thank you for your attention. We kindly welcome you for next webinar in July. In between, we will do a follow-up, and if it is permissible, we would love to visit you, all of us, or our sales contacts on your territory. Up till this point, everybody stay healthy, keep well, and we look forward to the next webinar.
Thank you very much.
Thank you. Thanks, everybody.
Thank you. Bye.
Bye.
Thank you.
Bye-bye.